All right, hey guys, so we are moving on to lesson 3.5. All right, so let me present my screen and we'll get started. Okay, let me scroll to the top. All right, so we're going to be starting with vocab term directed line segment. A segment that a segment that represents moving from point A to point B is called a directed line segment AB. All right, we're going to be working with that in one of the example problems in a moment. Some of this lesson is going to be a review because we're going to be talking about slope-intercept forms, slope of a line, slope of parallel lines, slope of perpendicular lines, writing equations of lines, which is all stuff you learned and studied in Algebra 1. All right, so slope of parallel lines. Hopefully you guys remember that when you have parallel lines, the slope is equal. Where did my flow thingy go? Hold on one second, guys. I need to find something. Oh, here it is. There we go. I didn't see that before. So when you have parallel lines, the slopes are equal. We use M to represent the slope of a line. So whenever we have parallel lines, non-vertical parallel lines, then the slopes are equal. All vertical lines are always parallel to each other. All right, so then let me scroll down. I forgot to put this in. Okay, sorry about that. Slope of perpendicular lines. Hopefully, again, you remember from Algebra 1 that when you have perpendicular lines, the product of their slope is equal to -1. Okay, so you may remember, like, if one line has a slope of 3, the other line has a slope of -1/3. We say that their slopes are opposite reciprocals. Opposite meaning one's negative, one's positive. Reciprocals flip the fraction, right? So that is what we teach you in Algebra 1. But also, if you take those two slopes and multiply them together, you get a product of -1. All right, so that's what this is saying here. These two slopes have a slope of -1. But again, you can think of it as opposite reciprocals. All right. Now, special cases, and we'll talk more about this before we jump into some example problems probably in the next lesson. Vertical and horizontal lines. A vertical line has a slope that's undefined. Okay, remember, slope is always rise over run. And if you have a vertical line, there will be no run. 0 will be in the denominator. You can't divide by 0, so it's undefined. Again, for horizontal lines, rise over run. Now you'll have a rise, but you won't have a run. So we say that the slope is 0, okay, for a horizontal line. All right. Let's keep going. Okay, so the first extra practice problem, this is new, and this does take a little bit of thought. It says in exercises 1 and 2, find the coordinates of P along the directed line segment AB such that AP to PB is in the given ratio, 3:1. Okay, so I'm going to show you what I think is the easiest way of doing these problems. It's a little bit different than what the textbook shows. So if you're looking it up in the textbook, it might be explained a little differently. All right, but you are going to want graph paper for this. All right, so I'm going to just make this big so that you can see what I'm doing. All right, so I'm going to do problem number 1. I'm going to plot a point at -2, 7 and another point at -4, 1, A and B. So let me get my pen again. -2, 7 is right here. That's point A. And then -4, 1. Come on. Is point B, okay? And then you're going to connect them. This is B, this is A. Try to draw nice. Oh, that wasn't nice. see if I can erase that without erasing the point. Try again. All right, that's pretty good. Okay, so you want to find this point P. Point P is somewhere along this segment, and point P has to be in the ratio of 3 to 1. All right, so again, it says you want this directed, or this point P along the directed line segment AB so that AP to PB is in the given ratio, right? The distance from A to P and then the distance from P to B is in the ratio of 3 to 1. So the first thing you're going to want to do is think about that ratio for a second. 3 to 1. That means 3 parts away from A and only 1 part away from B. So how many parts are we going to be breaking this segment into? It's going to be a total of 4 parts. Okay, 4 parts. And that 4 I got by simply adding the 1 and the 3 together. 3 parts and 1 part is a total of 4 parts. Okay, so we're going to think about dividing the segment into 4 parts. So think about dividing the segment into 4 parts. Okay, that's the first thing you need to think about. All right, so we want point P. So point P is 3/4 of the way from point A to B. All right. So what we're going to do is we're going to find the slope. That's the key here. Find slope. All right. Rise over run. So we can just count, or you can plug into slope formula if you want. Okay. So how many units am I rising? And then how many units am I running? And we can just count. 1, 2, 3, 4, 5, 6 up, and 1, 2 to the right. So 6 up and 2 to the right. All right. So we're going to find P by, actually, let's do it a different way. If I'm going 6 up and 2 over, or let's go the opposite direction. Let's go 2 over and 6 down, right? If you divide that in half, we would be going 1 over and 3 down. 1, 2, 3. So I'm going to put a point right here. That's the midpoint of the segment, right? If I, instead of going 6 over, or excuse me, 2 over and 6 down, I went 1 over and 3 down. So I just broke it into 2 equal parts. So now let's break this into a half as well. So what I mean by that is from this point to that point, I have to go 1 over and 3 down. So let's only go half the way. Let's go half the way over and 1.5 down, right? Instead of 3 down, so 1.5 down. That's right here. Oop, oop, put it there. And then from here to there, again, it's 1 over and 3 down. So let's go half of a unit over and 1.5 down. That's about right here. All right, so I just broke our segment into 1, 2, 3, 4 equal pieces, right? 4 equal pieces. And if this point P is 3 to 1, right? If I go 3 parts away, 1, 2, 3, that would be point P. This would be point P. All right, and point P is in the ratio of 3 to 1. It's 3 units away from point A and 1 part of the way from B. So now we have to figure out what the coordinate of that point is, and that's where it's a little bit tricky. Okay, I kind of broke it into pieces so you can visually see where it is. But what you want to do, let me erase some of this so I have more room. Remember that slope of 6 over 2. you're going to find P, you're going to subtract 3/4 of the run to the x coordinate and 3/4 of, that's a 3, by the way, that's a 3/4 of the rise to the y coordinate. All right, so what exactly do I mean by that? So let's find 3/4 of the run and 3/4 of the rise. Remember the slope? Rise over run was 6/2, which I didn't simplify on purpose. So if I find 3/4 of the rise, what's 3/4 times 6? 3/4 times 6 is 9/2. And then if I find 3/4 of the run, 3/4 times 2 times 2 is equal to 3/2. So then what you do is you take the coordinate of A, -2, 7, that's the coordinate of point A, and you're going to subtract 3/2 from the x, and you're going to subtract 9/2, there we go, from the y value, okay? Because rise, y value, run, x value, right? And when you do that, you get -3.5 and a +2.5. Now, if you were like, I could have figured that out just by looking, right? If you count from the origin 1, 2, 3, and we were halfway in between, so it's 3.5, and then 1, 2, and halfway as well. You could have figured it out just by counting as well, but I wanted to show you algebraically how to figure it out. So now you know how to do it just using the coordinate plane, and you also know how to do it algebraically, okay? So that one's kind of a lengthier problem. Let me make this coordinate plane small again. Okay. All right, so the next problem says determine which of the lines are parallel, which of the lines are perpendicular. Well, what's important when determining lines if they're parallel versus perpendicular? I mean, there's no boxes to show right angles, there's no arrows to show parallel lines. How do you determine parallel and perpendicular lines? You look for their slope, right? We want to know the slope of all the lines. Now it's going to save you time in the long run to find the slope of all the lines. So over to the side, I'm going to write slope of P, line Q, line R, line S, and line T. All right, so to find the slope of each line, we can count, we could plug into slope formula. It's kind of up to you. So here's line P. Pick 2 points on the line, any 2 points. I'm going to look at this one and then this one and count, rise over run. I'm going up 1, 2, 3 units, and to the right 1, 2, 3 units. So it would be 3/3, which is a +1. Then go to line Q, pick any 2 points on the line. Well, there's only 2 points to pick, this one and this one. I'm going to rise 1, 2, 3 units, and I'm going to run 1, 2, 3 units. So again, it's 3/3, which gives us a slope of 1. All right, line R, where's line R? Here's line R. Pick any 2 points on that line. There's only 2 to pick from. So from this point to this point, I'm going to rise 1, 2, 3. I'm going to run negative 1, 2, 3, 4. So it's a +3, -4. So the slope is -3/4. S. Where is line S? Here it is. Pick the 2 points and you're rising 1, 2, 3 units, and you're going to the left, so it's negative 1, 2, 3 units. So it's a 3 over a negative 3, which is negative 3, that is, which is a negative 1. And finally, line T. Here's line T. I'm rising 1, 2, 3 units and running to the left 1, 2, 3, 4. Left is negative, so it's negative 3/4. Okay, so we were asked to determine which lines are perpendicular and which lines are parallel. Same slope, parallel lines. Same slope, parallel lines. So I know that P is parallel to Q, and I also know that, where's the negative 3/4? R and T. R is parallel to T. All right. Now, opposite reciprocals means you have perpendicular lines. So 1 and negative 1 are opposite reciprocals. So Q and S are perpendicular. Q is perpendicular to S. And then also 1 and negative 1 again, P and S are perpendicular as well. P is perpendicular to S. All right, so 2 sets of parallel lines and 2 sets of perpendicular lines. All right, let's see. Delete, get my mouse to move. Tell whether the lines through the given points are parallel, perpendicular, or neither. Justify your answer. Okay, well, think about what we just did above. How do we determine if lines are parallel, perpendicular, or neither? We calculate their slope. So I'm going to calculate the slope for line L. So slope for line L, or 1, that's a 1, not an L, sorry. Slope of line 1, you're going to do change in y, so 2 minus 0, over change in x, negative 2 minus 2. All right, if you don't remember slope formula from Algebra 1, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just like I said in the distance formula, you actually could also write that as, I'm going to write or. You can also have it as y sub 1 minus y sub 2. It doesn't matter if the sub 2's come before the sub 1's or vice versa, as long as you're consistent in the denominator. So if you're always like, oh, I don't remember, is it sub 1, sub 2? It doesn't matter as long as you're consistent. So both of these will work, okay? And then you can label your points x1, y1, that's an x, and then x2, y2, and then you're just plugging in. All right, so the numerator is a positive 2, and this was minus a 2, I think it was. And this should be, if I'm remembering correctly, negative 4, which is going to be negative 1/2, okay? And then we're going to find the slope of line 2. So it's change in y, 4 minus negative 2, over change in x, 4 minus 1. So that's going to give you a 6 over 3. So that simplifies down to 2. Or if you want to look at it as 2 over 1, you could always do that as well, or just 2. All right, so if I have a slope of negative 1/2 and a slope of 2, are these lines parallel, perpendicular, or neither? Opposites, meaning one's positive, one's negative. Reciprocals, right? If you flip the fraction, you get what you see the other one has. So these are perpendicular lines. So line 1 is perpendicular to line 2. You could also say it's because if you take their slopes and multiply them together, you get a product of negative 1. It's also how you determine that the lines are perpendicular. All right. Let me go down. Okay. Next it says write an equation of the line that passes through the point 3, negative 2, and that is parallel to y equals 2/3 x minus 1. Graph the equation of the line to check that they are parallel. All right, so if you want a line that's parallel to this line, that means you're going to steal the slope, right? Lines that are parallel have the same slope. So steal the slope. That means that your line has a slope of 2/3 and your line goes through the point 3, -2. In order to write an equation of a line y equals mx plus b, you need to know two key pieces of information. You need to know the m, the slope, and you need to know the b. You know the slope, you can plug that in, you don't know the b. But you have an x and a y to work with. So plug those in and then you'll solve for b. All right, so it's -2 equals 2/3 times 3 plus 3 plus b. So that's -2 equals, cross simplify, 2 plus b. Subtract 2 from both sides and you get b is equal to -4. Once you know b, then you can go back and write the equation of the line in slope-intercept form. Because again, you need the m and you need the b. So you have y is equal to 2/3 x minus 4. Okay. All right, now for graphing purposes, let me make my x and y axis nice and dark. So here's my y, try to get it straight. Here's my x. So when I go to graph, I'll graph the equation they gave first. So the y-intercept is at -1, plot a point at -1. Then you go up 2/3. Up 2/3. I could also go down 2/3. Down 2/3. All right, and you draw your line, try to get straight. All right. Now, the new equation has a y-intercept at -4. 2, 3, 4, plot a point. Same slope, up 2/3. Up 2/3. Or down 2/3. And you can see visually that your lines are parallel. Okay. Write an equation of a line passing through the point -2, 2 that's perpendicular. So this is similar, all right? But if your line is perpendicular to this line, that means you're going to take the slope and then use the opposite reciprocal. So your slope is going to be -1/2. So that's your slope. Your point, remember your x and your y are 2 and -2. You don't know your b. So same setup, you're going to write y equals mx plus b. Plug in everything you know so you can solve for b. So you're going to have 2 equals -1/2 times -2 plus b. So you have 2 is equal to, and you're going to multiply, right? Cross simplify as you do. Negative times negative is a +1 plus b. Subtract the 1 from both sides and you get b is equal to 1. Once you know that b is equal to 1, you can write the equation of your line. So it's y equals -1/2 x plus 1. You need the m and the b, which is what you have, and you just plug them in. So then, just like I did above, I'll start by making my y-axis nice and dark and my x-axis nice and dark. I'll first graph the equation that was given. They gave a y-intercept of a +3. And then the slope is a +2, so up 2/1. Or down 2 to left 1. 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 Okay, so that's the equation that was given. And then your equation that you wrote has a y-intercept at +1. And then your slope is -1/2. So down 1 to the right 2. Come on, down 1 to the right, down 1 to the right 2. Down 1 to the right 2. Or it could go up 1 to left 2. Up 1 to left 2. Up 1 to left 2. And draw your line, and you can visually now see that they are perpendicular. They intersect and form a right angle. All right. Okay. It says find the distance from point A to line y equals negative 3x minus 5. Okay, this is a multi-step problem. Okay, in order to find the distance from a line, or excuse me, find the distance from a point to a line. All right, if I visually just kind of sketch this real fast, or I won't even really sketch it, I'll just show you something real fast. If you have a line and you have a point not on the line, in order to find the distance from this point to the line, we have to find the perpendicular segment, right? Because we want to measure the distance in a perpendicular segment, okay? So what we're going to have to do is we're going to have to find the equation of the line that's perpendicular to this line. That's the first step, okay? So first, find equation of line perpendicular to y equals negative 3x minus 5 that goes through point A. Okay, so that's the first step of this multi-step problem. So just like we did above, if we want a perpendicular line, that means I'm going to use the opposite reciprocal slope. If the slope is negative 3, my slope is going to be 1/3. I am given point A, which is 0, 5. That's my x and my y. I need to solve for my b. You might already recognize your b. If so, that's fine. If not, I'll just be consistent with how we're doing the problems. Y equals mx plus b. Substitute in the y, substitute in the m, substitute in the x, and solve for b. You have 5 equals 0 plus b, so b equals 5. The point was actually given. That is your y-intercept. All right, so let me erase this stuff. So now the equation of the line is y equals 1/3 x plus 5. So now I have this line and I have this line, and they're perpendicular to each other, and they go through that point A, okay? So the next thing you're going to do is find the point where those two lines intersect, because in order to find the distance between two things, I need to have 2 points. I have 1 point, but I need the other point, which is the point of intersection. So so second thing, find the point of intersection. In order to find the point of intersection, you could graph, but I'm going to solve it algebraically. So I'm going to write the two equations down. Y equals negative 3x minus 5, and y equals 1/3 x plus 5. And I'm going to solve using a system of equations. So I'm running out of room here. Hold on a second. Get rid of this for a second. I'm going to use elimination by subtracting one equation from the other. All right, when I subtract, my y's are eliminated. Negative 3 minus 1/3, that's the same thing as negative 3 plus negative 1/3. That's negative 10/3 x. And then negative 5 minus 5, that's negative 5 plus negative 5, which gives you negative 10. And it's a 0 on this side because the y's were eliminated. All right, so then I have 0 is equal to negative 10/3 x minus 10. I'm going to add the 10 to the other side. I'm trying to isolate the x, so add the 10. Now I have 10 is equal to negative 10/3 x. Now I'm going to multiply both sides by the reciprocal of negative 10/3, so that's negative 3/10, and that's going to leave me with an x value of negative 3. So now that you know your x value is negative 3, you're going to take one of these two original equations, plug in the x to find the y. So I'm going to use the equation that doesn't have any fractions. I'm going to have y is equal to -3. Instead of x, you're going to plug in the x value, which is -3 minus 5. So it's y is equal to 9 minus 5, so y is equal to 4. So now I finally found where they intersect. They intersect at -3, 4. Okay? So the last step is to take that -3, 4, that's where they intersect, and this point A that was given, 0, 5, and calculate the distance. Distance is equal to difference of the x's, -3 minus 0 squared, plus the difference of the y's, 4 minus 5 squared. So that's going to be -3 squared plus -1 squared, which is going to be 9 plus 1 square root of 10. All right. And if they ask for a decimal approximation, you would give me 3.16. Again, you have to read the directions. If it doesn't say round or approximate or anything like that, you leave it in radical form. Okay. All right. So that is all I'm going to cover for that lesson. I will see you back here for some more equation stuff, linear equation stuff. Bye.